Question 3 is about conservation and people, my favourite. The two, you can't have one without the other. So I'd like to introduce to you, we have Kathryn Sinclair, the Great Victoria Desert Biodiversity Trust, to talk about surveying for malleefowl in desert environments. Can you please put your hands together for Kathryn?
So I actually changed it to surveying for malleefowl in the Great Victoria Desert because that's where we actually did it rather than desert environments. But yes, I'm Kathryn Sinclair from the Great Victoria Desert Biodiversity Trust. And yeah, I'm here to talk to you about the surveys that we've done across the desert. I also want to acknowledge the traditional owners and thank their leaders past, present and emerging for the stewardship of the country. So as an overview, I'm going to talk a little bit about our organisation because we're a bit of a unique model in terms of how we were created and what we do. Then I'll talk about malleefowl in the GVD, and spoiler alert, we don't know very much. Next, I'll talk about the methods we've used for surveying for malleefowl in the GVD and how we came to choose those processes, where we went and the results we got. And finally, I'll discuss what we're thinking about doing next and get your ideas, hopefully, on some ideas that you might have from all the conversations that have happened so far. So the Great Victoria Desert Biodiversity Trust was established in 2014 by the Tropicana joint venture partners. They were creating the Tropicana gold mine, which is in the middle of the region. And it was determined that they were going to have some impacts on matters of national significance, particularly the sandhill dunnet and the malleefowl. So given the region is largely intact, they had to think about how they could offset what their potential impacts. And what they came up with was the development of the trust as an independent model. It has me as the operations manager and reporting to a board, which is comprised of members from DBCA and the gold mine. So it was interesting that they decided to have that industry government partnership to keep industry involved and participating in the process. And we also have a technical advisory panel made up from experts from the region, and they're all volunteers who contribute their time and help us develop the projects we do. So the purpose of the trust was to fund on-ground research and on-ground management of threatened species and their conservation in the area. So in our area, it's incredibly poorly researched. It's a really remote region. So we acknowledge that we need to do research, but that research should be practical, that we should be able to implement on-ground actions as a result of that. And another key aspect of the trust is that we need to operate at the landscape level. In the region, the threats aren't localized to one particular area. Most of the threats are across the whole landscape. So you need to consider that in any actions that you take. So for those of you who aren't aware, the Great Victoria Desert is the largest desert in Australia. It's the 7th largest desert in the world, and it covers approximately 420,000 kilometres. We at the Trust focus on the WA side of the border, and I think we've had Brett give a discussion on the South Australian side, but I missed that, unfortunately. And it's one of the areas with the lowest rainfall in Australia. We get approximately 160 mils a year, and that's quite variable. So some years it's substantially less, some years it's more, but some of the lowest rainfall across the whole of Australia. So malleefowl in the GVD, very little is known. We're out there, we're trying to get a gauge of their population, of the trends, but really we have limited information on what is going on with them. There's been some work done on the South Australian border, as Brett has talked about, with the APY lands and Maralingua, but on our side of the border, there's very limited information. As I mentioned in quite a few of the discussions, they're very hard to detect. They're well camouflaged, they're shy, they're fast, and they're rarely seen or heard. So in an area like the GVD, where we expect that amount to be, the numbers of malleefowl to be really low, they're even more difficult to detect. Breeding is thought to occur much less frequently in areas like the GVD, where the rainfall is so low. Malleefowl often breed in response to rainfall events. So where they occur less frequently, they're going to get lower breeding rates. in our region, we have threats that are a bit different to quite a lot of the discussion that's taken place so far in terms of fragmentation of landscape and clearing. We don't really have those threats out there. Chiefly, we have large-scale fires as the chief threat to the whole country. We get these massive fires come through. They can be up to 100,000 hectares and just decimate the landscape. Ferals are out there as well. We've had cameras out and you can see particularly cats, but there are a lot of dogs and a few foxes as well. And climate change, how that's impacting our region. So mounds are one of the few ways of actually detecting malleefowl out there, even though they breed less frequently. So there's going to be less mounds or less utilised potentially, but they are one of the few means to get an understanding of the population out there. Also just highlighting that the region is really inaccessible. There's no major towns in the region itself. There's a couple of Aboriginal communities, but it takes about 5 or 6 hours to get there from Kalgoorlie. So if you go out there, it's time consuming, it's costly, and you have to really be completely independent. So we knew we wanted to survey for mounds, but we had to think about where we wanted to survey. So there were some existing known mounds, and those mounds are mainly done through a very few number of fauna surveys which have taken place across the last 30 years, as well as some exploration companies which have found mounds as they kind of explore the region looking for gold and other minerals. So we tried to contact them, get as much information as we could on the existing mounds. We also noted that because in that region very little research has been done, we wanted to survey not only for where we knew the mounds were, but to look at other areas where potentially no surveys had taken place, so that they might exist there and we just haven't looked. So really diversifying there, we wanted to look where they were and where they potentially weren't. Also, given that remoteness of the region, we wanted to be able to ground truth the mounds, and we knew that from the outset. So we were going to follow tracks. It's not very many tracks out there, but we wanted to make sure that anybody who was doing ground truthing could actually be able to reach these mounds, and that they were within a reasonable distance for the roads for safety. Also, when we were trying to work out where to survey, we spoke for the traditional owners in the region. There's 2 or 3 groups in the region. We kind of weren't going too far north, but we spoke with the Spinifex in the east, and they at that stage, they didn't want to participate in the surveys or have any surveys taken across the country. So we respected that. And then we spoke to Yilka, which is in the northeast, and they were keen for some surveys on their country with certain parameters, making sure we didn't go to key areas that they didn't want us to go to. So based on that, we came up with this map. The dark blue areas show the areas of high suitability, which is all in that southwest corner. We initially had looked at that, if you can see the orange line, as a north-south line and east-west line to get a diversity of different mounds potentially in areas that are low and high suitable habitat. But we also worried that if we did surveys out there, given their low numbers, we wouldn't actually detect anything. So we decided to do a survey that encompassed those bits of those north, south, east, west lines, but also focus on that southwest corner so that we would hit some mounds. So choosing how to survey for malleefowl, we discussed 3 main options to survey, which was doing ground-based searches, particularly in the form of long walks, where you follow alongside a road at a certain distance, kind of doing tag team. But again, because of the low number of mounds and the cost of utilising, the cost of getting out there and having people in remote regions, we decided not to go for ground-based searches as an initial option. So that left us with 2 main options to consider: the aerial, which was photogrammetry and LiDAR. We examined these ones extensively and did kind of cost-based analysis over the sort of level of area that we wanted to cover, and LiDAR came out slightly cheaper, and it was also the preferred method for a lot of different experts that we spoke to. We also selected to go with LiDAR with Ortho Photo. So Ortho Photo comes with an additional expense, but I'll go into what Ortho Photo is and its benefits in later slides. And we always knew that we wanted LiDAR to be followed by ground truthing. It's that LiDAR is known to be able to generate lots of, some false positives as well as false negatives, as well as LiDAR. Ground truthing just gives you lots of additional benefits in terms of what you can see, the activity of the mound, the habitat that they exist in. So we decided to go as our survey techniques, LiDAR followed by ground truthing. Obviously, quite a few presenters today have spoken, and yesterday spoke about the LiDAR process, which is light detection and ranging. For us, this involved getting the plane out and flying really low over the landscape to get as many cloud points as we possibly could. And I don't know if it's been gone through by anybody else, but when Anditi, they were the company that we commissioned and they're kind of acknowledged as having the best algorithm for detecting mounds, they classify they do an auto search with their algorithm, which will look at all the land that's surveyed and rate each of these, rate the different data points that they detect related to how closely they resemble the typical mound. So with class 1, they're very high confident it very closely resembles a typical mound. Going to class 2, which is still confident, with levels class 3 and 4 being progressively less confident that it is a mound. So these green lines, which look a bit higgledy-piggledy, but those are the areas that we ended up doing the LiDAR on. That little nest in the bottom corner is the high suitable areas, and then you can see the kind of traces of going north and going east and west there as well. So in terms of LiDAR outcomes, we surveyed 1,675 kilometres at 600-metre wide intervals, and that equates to just over 100,000 hectares flown. And what they found was 102 class 1 mounds, so highly confident, 22 class 2 mounds, and I'll come back to that one, and progressively larger amounts of class 3 and class 4, which they're progressively sure that are less likely to be mounds. So these are the ortho photos, which, as I said, I'm coming back to. The ortho photo is an image that has been geometrically corrected or ortho rectified. And you can see there very clearly what that ortho photo does. It's essentially, it's taken that you can use it in the same way as a map. It allows the data to be searched visually. And so what Anditi did for us in this context was they looked at all the class 1 and 2 mounds that they'd found. And initially they'd found 122 class 2 mounds. They went through, looked at the ortho photos, and actually found 100 of these were spinifex. And you can see there how the spinifex can very clearly resemble a mound if you were looking at that from just a pure data algorithm point of view. So we saw the clear benefit there in getting the ortho photo, because you've therefore saved a lot of time and expense in going out looking at those points. The ortho photo combined with LiDAR, they're giving you a whole lot of data as well, which can be utilized. Is really it's really interesting what you can get from the LiDAR, that 3D imagery combined with the ortho photo, which gives you a really clear representation of what the vegetation is. So that's what that all looks like on the map, with the green points being the class 1, the blue ones, if you can see them, being the class 2, and all those purple lines, or purple dots, which are pretty much everywhere, are those class 3 and 4. So next we did the ground truthing, and this was undertaken by the National Malleefowl Recovery Group in July of last year. We were really lucky that they were able to get out there. I think they managed just to get through in the right times in terms of COVID. So we were really lucky that they were able to come out and do that survey. Because of the COVID issue, they were initially going to survey all the class 1 and class 2 mounds, but because of kind of the COVID issues and access, we worked with them to determine a selection instead. And they surveyed 71 of the class 1 mounds, and that they found 99% of those were actually mounds. And they surveyed 10 of the class 2 mounds, and 80% of those were actually mounds. And there's a dramatic drop off there with the class 3 and 4 mounds going to 4 and 2%. They're really not likely to be mounds at those rates. So as I said, ground truthing gives you a lot of additional benefits just to knowing whether the mounds are actually mounds. They gave us information in terms of the habitat that we're most likely to find malleefowl mounds in this arid area, which here it's woodland, typically comprising of mulga with a diverse understory. They were also in lower shrubland, including regenerating mulga. Over 74% of the mounds were estimated to be in vegetation that's over 20 years old, which is a really significant finding for our region. And 16% of the mounds were in areas that have been recently burnt, indicating that there's a huge prevalence of that fire and how that has the potential to really shape the landscape. So that is an image of all the class 1 and class 2 mounds. And that's where the ground truthing team went. So focusing on that corner, but they did a great job. They also looked for us at the reasons why there were those false positives. You can see there that anything that kind of could cause a lumping effect on the ground is what the algorithm is going to detect. And it was quite often human disturbance, soil built up around a bush, tree uplift, or they couldn't see anything at all. So there's quite a few things that they're going to detect under that LiDAR, which are going to generate the false positives. But fortunately, they're not mainly in that class 1 and class 2. So the results from the ground truthing is that they didn't find any active mounds. They were searching in July, where the malleefowl searches typically take place in October to January. So it wasn't particularly surprising that there were no active mounds, but still disappointing. There was eggshell detected at 30% of the mounds. 80% had a crusty surface, which indicated it hasn't been worked for a few years. There was evidence of malleefowl presence in 10 mounds in the last couple of years, and an additional 14 mounds had some evidence that they've been worked in the last 2 to 5 years. So the ground truthing also told us some really interesting information about the kind of on-ground situation as well as LiDAR. So if you recall, we were doing 600-meter tracks, 600-meter wide LiDAR paths following tracks. And what they actually found was that the LiDAR points ranged up to 1.7 kilometers away from the tracks with an average of 760 meters. So that indicates the difficulty the plane may have had in following closely to the tracks, and also how the plane might have been affected by wind, and that could potentially change the angle at which the LiDAR is taking place when it's looking at a narrow path like the 600 meters. LiDAR had also failed to detect 2 mounds. These were both low mounds, under 15 centimeters. So the National Malleefowl team didn't think this presented too much of a problem because those low mounds are less likely to be revisited. As I mentioned previously, the mounds were visited in July rather than October to January, which is the recommended period. So yeah, that kind of shapes our results a little bit. Fresh prints were found at 6% of mounds, and most mounds were covered in this buckshot gravel, making it quite difficult to detect prints anyway. It's also noting that the conditions were exceedingly dry. The rainfall for the past 4 years was 25% below the long-term average. So and the team, the ground truthing team, noted that there was absolutely no vegetation, like no fresh herbaceous vegetation for the malleefowl. So that they're persisting out there is pretty remarkable. So there's lots of different things we can do with this information. So we can begin to understand the potential density of malleefowl in regions and arid regions such as the GVD by examining the number of mounds detected and the amount of suitable habitat. We can also use that data generated, and we've been working with DVCA, their remote sensing team, to try and get better maps, the vegetation maps of the entire region. That's by understanding the vegetation, you can better understand where malleefowl may be. The most common form of mapping at the moment is just Beard's vegetation mapping, which is a very coarse level. Oops. Oops. Sorry. Is there a way I can go back? I was pressing the back button. Yes, so all this information can help us to understand where to target future searches and where we need to focus our management actions as well. So one action that we're doing as a trust is this initiative we're called the Landscape Conservation Initiative. It's essentially a paired landscape project in which we've got a reference area and a management area. So unlike the adaptive management project, which is looking at ferals, we're focusing on fire because that's identified as one of the what we think is the chief threat. In that reference area, we'll be doing fauna monitoring. We'll be examining the mounds in the area. And yes, so the aim is to work on that management area and conduct cool, culturally sensitive burns and protect areas of core sandhill dunnet habitat and malleefowl habitat. And as a second stage, we're going to move into predator control. And the management areas and the reference area are both about 30 by 30 kilometres. They were selected based on a diversity of fire age history. So these are the different activities we're undertaking within that landscape conservation initiative. So we're going to monitor the mounds within those areas. We're going to conduct the pitfall trapping. We've had the first year of that already, and we want to see if the introducing fire and preventing large-scale burns can lead to greater biodiversity, better community assemblages of plants and animals, and also help the key species, the sandhill dunnet and malleefowl. We'll increase the malleefowl knowledge through transects and long walks associated with the fauna surveys. And we're also conducting vegetation and soil sampling. We've recently installed 2 weather stations, 1 in each of those areas. Collecting that out in that region, it's really remote. There's not much information, accurate information anyway, on the weather out there. So we can get a much better understanding of the localized rainfall patterns and temperature. Yeah, and as I said, the fire management activities that we'll be doing is to chiefly protect against those large scale burns, which will just decimate the habitats out there, and they can leave it to bare ground. So we feel like that's a really important project that we're working on, and to demonstrate the benefits of that. We are putting out camera traps. So the Trust has 65 cameras, which we've left out for 6 months periods at a time. We're also considering putting those along tracks and considering how we'll put those to get the best understanding of predators in the region, so that we can progress towards feral predator management and see the best way to progress with that. One of the things we want to do is work more closely with traditional owners. We've worked with Spinifex and Yilka and on smaller scale projects, but we know that they have a whole lot of valuable knowledge and valuable techniques for searching for malleefowl. So we want to work with them on areas that they identify as priorities and the practices they'd like to undertake. So for this presentation, I wanted to thank the National Malleefowl Recovery Group. A lot of the information on the report comes from them. They did a fantastic job ground truthing for us, and we couldn't have asked for anything more. And also Andretti, who did the LiDAR and report for us. So thank you very much, and let me know if you have any questions.
Any questions for Kathryn? One down the front, Kathryn.
Kathryn, do you have an overall confidence figure for using LiDAR to locate the mounds? And I assume you use a manned aircraft for carrying the LiDAR. Have you ever trialed drones for this work?
We haven't trialed drones as a part of a concerted study. We have had somebody come out with us on when we're doing some of our work, and they tried to, just get the drones up looking for known mounds, and they did find it exceedingly difficult. I guess it's even looking for known mounds with drones. We've had that presentation, which was fantastic, on the use of drones for monitoring. They're really difficult to detect, even when you know where they are, and at least with the drone that we were using, that's a very limited view path that you have. So yeah, I think it's something, as the technology progresses, we definitely want to look towards, because we don't, in our management area and reference area, we don't know how many mounds there are. We can only kind of extrapolate based on the data. But yes, in response to your first question, don't know the exact kind of percentages, but we did get that, they were highly likely to detect those. In our area, at least, I know that different areas have different results, but they did find that class 1 and 2 mounds were highly likely to be malleefowl mounds.
It's a comment, really. In 1991, I was out at Queen Victoria Spring, and the people out there, the Kanana people, were actually taking eggs from the mounds and eating them, but leaving the birds.
Yeah, I've heard that still around spinifex, where the spinifex community, it is, you know, it's always been considered part of the diet. So there is some of that still going on.
Right.
Great that you recognise the impact of fire on mallee fowl as a threat. We certainly see that down on the south coast. Interesting to note with the traditional owner burning program, have you sort of seen any cultural burning practices happening out in that area, or is there something going to be built into your research about that?
It's a really good point, and it's something we're working closely with 10 Deserts, who are now IDA on. They've got a lot of fire skills and work with a lot of groups. So we're hoping to build a partnership with them. I think Yorka in the north, they do a bit of like ad hoc fire management, that if they stop by the side of the road and see that an area needs burning, they look at the health of the country. They'll do some burning. It doesn't seem to be as part of a spinifex. They haven't automatically kind of incorporated it more into their practice. So we're hoping to work more closely with the ranger groups. One study we did do was we got the earliest available photography, which was when the traditional owners were living on country, which was in the earliest available we could get was the 1960s. And you could get the fire scar patterns created by the traditional owners there versus the current massive landscape fires, which occur when there's no traditional owners or not extensive burning going on. And the scale is just unbelievable. These small fires that they could get happening across the landscape just show how well managed it was.
I've just got one question following on from the fire side of things. I saw a presentation earlier that Noddy did, and some of the data was showing that they're coming back in that sort of recent burnt areas, and yours for those, I think it's 13%. Is there any follow-up after fire in terms of predator control baiting, and any further research into how early they're returning to the area?
I haven't got any data on hand of that, because we just did this last year, the ground truthing, but I think it's something we really need to consider, in that predators are obviously known to move into that recently burnt area. So it's something we're going to have to closely get an understanding of, because we do want to do predator control if they're going to have a negative impact on the species, and see how that relates to the burning programs that we implement to prevent the large scale fires. Does that answer your question?
Kathryn, what stood out for me is the whole, when we're going out on country in Australian soil is Aboriginal country, and that you've asked permission first. So that's a big start to relationships with traditional owners. Ask for permission first. Then ask, what do you want? So not going in with a plan or a grant, actually turning up and saying, what would you like? And if we're going to do something together and co-design it together, we need to hear from the traditional owners what it is that they would like from it, not us appearing and saying, let's do this. So that was I love that slide. That slide, you know, it's essential. It really is to ask first. So a wonderful presentation.